Now then, we've got a Fronius single phase grid inverter, and I've not played with one of these before, so let's investigate. I'm assuming it's got a fault, which is why it's here. Can we fix it or can we not? There are one or two things that, just looking at the label, make me think, that could be awkward, but I'm going to cover those later. I think the first thing to do is to point out a few features which are different. It feels like it's very well made, and looking at the design you think, well, that makes sense, they've done this, that and the other, but there are other things which you think, that's just introducing another layer of potential problems. So let's have a look then. The first thing, when you look at the bottom, you think, what? There's no MC4 connectors readily available. You think, what? That's a bit weird. An interesting thing though, there is what looks like a DC disconnect, which is good news, which is useful. I did look under that cover and it's not what you expect. There's communication ports in there and all that sort of thing. So the MC4 connectors or the DC in is not there. And then looking down here, you think maybe it's under that cover there. It looks like a cover, but it's not. So none of that sort of made a lot of sense. And because I've not had anything to do with these before, I wouldn't say dazed and confused, but I was thinking, what on earth's going on? I'm just going to turn this round and hopefully it'll give you a clue. So we have those, all I can call them is pins sticking out of the black plastic, and these slotted mountings, and then there are screws, 1, 2, 3 either side. So that sort of gives us a clue. So let's undo those and see what happens. And these fixings here are either slot headed, or they're a combination, slot headed and Torx heads. So I'll just undo those. They're not very long screws, but they're not self-tappers, they're properly threaded. So that's the screws undone, and there we go. So that lifts out. Let's just put that down. Focus. So what we've got there is a load of connectors. So what we've got there is a load of screw connections. I think that is the positive DC, that's the negative DC, and that's the mains. And then there's a load of screened pins that connect with the inverter. So yeah, nice idea, because this is the wall mounting and the inverter drops in there and it all connects together. But it's another layer of potential problems, so another connection that could give a bit of hassle. Let's just have a look at the inverter side of the connections. So hopefully you can see this here. There are the pins that connect with those other screen connectors. So there you go. Now we can connect everything up to the wall mounting part of this inverter and switch it on and see what happens. As usual, we've got the big variac and the isolating transformer and the rectifier and a smoothing capacitor. So let me just get that sorted out. Okay, here's the connections. Focus. DC positive, DC negative, earth, neutral, live. Okay, and the DC positive goes to the DC positive of the rectifier output. Black's negative, the one on your right hand side is the positive. Right, let's put her back together and wind it up. Okay, that's slotted into place. That's off at the moment. We'll switch the extension lead on. Now then, where are we? Where's the mains gone from this? Down there. There we go. Plug the mains in. The output of the variac is down and it's switched off, so we can plug in the variac, which is the white lead, wherever that's gone. Here it is. So let's plug that in. We had a whatever colour it was LED on there for a short while. Right, so plug that in. Okay, switch that on. Hopefully everything's alright. Yeah. Now then, we need at least, and this is the bugbear, .350 volts there. There we go. And that rectifier is only a 400 volt rectifier. So we've got DC going into it. And we've got nothing. Of course we've got nothing. Of course we've got nothing. So let's turn that down. Switch that on. And then turn that back up. That's 300 volts. But why have we got nothing? So you can't just take the cover off and check whether you've got mains going in there, because you have to take it apart. So we've got 300 volts DC there, 305, but we've got nothing there. Right. Okay. Let's switch it all up. Let's just unplug the mains and then plug it back in. Nothing. Wonder whether we've blown a fuse in that. Okay. Where are we? We've got the DC, that's fine. So we'll need to switch that off, turn that down, switch that off, unplug that, switch that off, okay, then plug this mains back in. And now we can check whether we've got mains there. Hopefully you can see that. We have got mains there. I'm just wondering whether it's one of these. Well, you've got mains there. But, you know, if you've got a slightly iffy connection there, the mains might not be getting through. Let's put it back together. Unplug the mains. Let's just have a look down there. Can't see any burning. Okay, switch that to on. Plug the mains in. Switch the DC on. Wind that up to about there. Where's my meter gone? There it is. On the DC side, $310, and it's on about 53 volts out of the variac. Ah, something's happening. Finally, I think we've got a duff connection on those. It says low DC. Okay, let's wind her off a bit. So there you go. I think we may have several troubles here. So I wound the voltage up to 370 volts. Let's go up a bit more. I'm just being a bit cautious with those rectifiers. 380 volts. Okay. Now, on this screen, there's a little, where are we? This creeps along like that, as if it's checking things. I'm just going to keep the camera running, just see what happens. The DC volt should be within range, you see. Yeah, there you go. Okay. State, is that 301. Right, we'll have to have a check over that, but that's as far as we can go at the moment, because there's no clicking or anything. It's not trying to start, so therefore there's I think it's a sensor fault. So just for interest's sake, I'll show you what's in here. They're captive screws there on these thumb. There you go, communication ports. And that's on a ribbon, so it's flexible. And that is DC, 12 volts DC, positive and negative. And then you've got these Ethernet type connections, and there's a relay there and stuff like that. So I've undone those 4 screws, and that just lifts off. It's sort of, there's 2 big ribbons there, so I wonder if I can disconnect those. There we go. It's one big connector, so that's that out of the way. So it's interesting. Let's have a look. So we've got 4 relays, and they're a similar sort of shape to the ones in the Aurora. There's a relay there, there's a relay there. These capacitors feel alright. There's some sort of connection there. Get that out of the way. I wonder if they're fuses down there. They look like they have removable covers. Can you see that? Those there, let's get a pair of pliers and see if they're removable. I wouldn't say they were fuses, but it's interesting. They're just solid lumps. So I don't think they'll blow. Alright, so you've got to have, that fits, hopefully you're catching this, that just fits in there. That's a very strange thing. Typical. They obviously decided they wanted fuses and then found out they were giving trouble or something, because that lump of steel is obviously, well, it might not be more expensive than a fuse. There we go. I don't think that would be giving the problem. And that's the DC in, so that's the DC isolator. And the AC is down this end. There's no stickiness. It's not as if one of the big capacitors has packed up or anything. It's a DC sensor of some form. Now I'm just wondering whether it's a connector. So let's jiggle a few. So those obviously probably not a problem. That's a relay as well. Bit strange. That's the DC connector, disconnect connector, switch. 6 relays. There's no stickiness, no duff capacitors, That red wire there goes to this fan. That white covered one, I don't know where that goes, but it goes underneath the board. Goes to something down in there. Can't see any immediate sort of burn marks or anything like that. There's a load of varnish on everything. There you go. It wouldn't have started to fire up and start the process if it hadn't seen a DC signal. So the DC was getting through and it wasn't saying no grid connect, so the AC was getting through. I don't like those connectors down there. There's nothing to pull them together apart from the physical weight of the inverter when the mounting plate is screwed to a wall. I'm going to leave it for now. I thought this was really quite well made, but there are some weird bits like these great big lumps of steel instead of fuses. Right, that'll do. And there you go, there's the label, and if you look there, maximum power point 350 to 700 volts, maximum voltage in 850, maximum current 8.8 amps. So I suspect this has been designed for relatively small output panels, high voltage, low current, and it's a 3 kilowatt inverter, P max 3000 watts.